Good afternoon, everyone. My name's Pete Osborne. I'm the director of the Innovation Launchpad Network Plus, and it's my delight to be able to introduce you to Tranche 3 of the Researcher in Residence scheme today. So we've got a reasonably packed agenda over the next hour or so. And as I said, we have Lydia Gardner joining us from the EPSRC today to talk about why the Researcher in Residence scheme is so important to the EPSRC and what they hope it will help to achieve. And then later on, we've also got some of our Researchers in Residence joining us. First up, we'll have Matthew Unthank, and then we'll be joined by Beatrice and Salome, who are part of our current Tranche 1 intake for this year's Researcher in Residence scheme. But first off, I'm going to tell you a little bit about the network. And the network's really been put in place to try and link up you guys, the academic community, with Catapult Network and help to provide a pipeline of new knowledge and new understanding through to the different industries that the Catapults support. We want to help to grow the maturity of that new understanding and new research, and to do that, we'll link you up with Catapults who've got access to new technology, new tools, and they will also be there to help to disseminate that new understanding and really help to create the impact that we're all looking to create from our work. And it's really important that, well, the key thing that this network's here to do is to enable collaboration. And the Researcher in Residence scheme is our primary vehicle to do that. So I'm going to introduce you to that over the next 5 minutes. And it's really important from our perspective that we're able to offer opportunities to a wider section of the university community as possible. So we're looking to try and promote mobility, to support academics and researchers who haven't worked with the Catapults before, and more broadly to encourage engagement between academia and the Catapult centres. And as I said, the Researcher in Residence scheme is our main vehicle for doing that. It's actually in its 3rd iteration now. The first iteration went by the name of the Catapult Fellows programme, and some of you may know the people that took part in that. Initially, that was set up to link up university-based researchers with the high-value manufacturing Catapult centres. The second iteration, the name changed, but the intention was broadly the same, but it expanded the number of Catapults that researchers could work with. And then this time around, it's been expanded to cover the entire Catapult network and give opportunities to work with any of the 9 Catapult centres. And it's really there to help you to translate your research, so the work that you've done within your own universities, into a much larger scale. And it does that by providing opportunities to work with the Catapult centres. Within this particular scheme, we have 3 key theme areas. And they actually align quite well with the EPSRC's remit and with UKRI's remit more broadly. And they're net zero, healthcare and well-being, and resilience. And I guess the key thing that we're looking for you to do as part of those residencies is also to think about the wider context of your research and ultimately how you're going to deliver impact through your project. So when you're thinking about ideas, we don't want you to just think about the great science that you're going to do as part of the activity. We also want you to think about, well, how are you going to convert it to impact? What are the things that you need to work with the Catapult to achieve? And how are you going to link up with their wider networks? And they're really important things to do, because obviously we want you to create as much impact as we possibly can from these activities. First phases of the scheme this year have been really successful. We've attracted significant number of expressions of interest. So I think we've now had more than 150 expressions of interest from academics and researchers at more than 50 different universities around the UK. And they've been across all three of our key themes. So net zero, resilience, and healthcare and wellbeing. And they've linked up those university-based researchers with all 9 of the Catapults. And Tranche 3 of that scheme launches today. So far, we've provided funding, well, we've announced funding opportunities to around 75 projects. And we've got the first tranche of those researchers underway. We're going to hear for some of those later. In the last week, we've allocated a further, I think it's about 45 funded opportunities to Tranche 2. And we're really interested to hear what you've got to suggest and to say that you want to work on in Tranche 3. The application process is quite simple. It's a 2-step process. First of all, and perhaps most importantly, we want you to talk to the Catapult that you're wanting to work with. Once you've had that conversation, we need you to register an expression of interest. And then as soon as we've checked that the project that you're proposing meets the rules, we'll send you out a full application form. Essentially, that expression of interest step, though, is there to do 2 things. First of all, we want you to confirm that you have actually talked to the Catapult that you want to work with. If you haven't, get in touch and we can make that connection. The second thing that we're looking to do with that expression of interest is really to help us to assess, well, how many different reviewers are we going to need for each of the theme areas? And it lets us get ahead. But as long as your project fits with the goals of the scheme and you're connected with those Catapults, then we will send out the expression of interest to you and you can get working on the full proposal. Within that full proposal, you can apply for up to £50,000 to cover things like your salary cost, any travel and accommodation and subsistence that you might need to get to and from the Catapult that you want to work with. And you can also apply for consumable costs, so consumable materials that you might be using during your placement. The Catapults will typically have some budget available to them to fund their staff and their time, so you only need to think about your own costs. Project activities need to be complete by April 2026, and that's when our grant finishes. So we need you to have finished all of your activities by the 31st of March 2026. And then the only, I guess, stipulations around who can apply is you need to either already hold a PhD or have a similar level of experience. So unfortunately, we can't fund PhD students or people working on PhDs at this time. And you need to be employed either in full or in part at an institution that would normally be able to accept research council funding. So principally, you need to work at a university or one of the independent research organisations that can receive research council funding. It doesn't just have to be you working on the project. However, in the application, you need to explain why that project or why that project team is the correct mix for your project. And also, importantly, it needs to stay within that £50,000 budget. But in terms of how you allocate that time between the different people, there's no set rule on that, but it needs to sound like a collaborative project. If you're reliant on somebody within your team to do most of the work, then maybe think about making them the applicant, because ultimately this is about individuals taking the knowledge that they have already generated through their research activities and helping and working with the Catapults to develop it further. So if it's somebody else that's developed that expertise, it might be better if they make the application. So that's the kind of the top level detail about the scheme. Now I'm going to hand over to Lydia Gardner from the EPSRC, who's going to tell us a little bit more about why researchers in residence is so important to the EPSRC and what it will help them to accomplish. So I'll hand over to you, Lydia. Hopefully we've made you a co-presenter, so you should be able to advance your own slides. But when you're ready, over to you.
Thank you. So thank you very much for having me. I'm just going to do a whistle-stop presentation, and I was asked to talk about the scheme from an EPSRC perspective, but also as joint head of manufacturing and the circular economy, who are one of the themes that have contributed funding for this activity, put a little bit of my perspective on it. My colleague Reese, I can see, is in the audience, and he's from our one of our teams in EPSRC who are also invested in this, so he's around as well. Thank you. If you could move to the next slide, please. So just want to talk a little bit about EPSRC and how we align within UKRI. I'm taking it as a given that people here know who EPSRC are, so I'm launching straight in. But if you do have any questions, please contact me afterwards. I'm very happy to have a conversation. But EPSRC broadly is looking to get a really balanced portfolio and supporting discovery and mission-driven inspired research and innovation. But a lot of what we do is not just funding research programs directly. We like to integrate and develop talented people and teams, develop a really broad and thorough research culture within that. And we also want to work closely with business and achieve impact in what we're doing. So the slide here demonstrates how EPSRC investments align to the UKRI strategy. There are some examples on this slide, but researchers in residence as a scheme really helps us to achieve multiple touch points on this. And we think it's a really valuable mechanism to help supplement some of the other things that we're doing to work in spaces that a lot of our traditional responsive mode funding might not achieve on its own. So we work with other parts of UKRI in order to do this. EPSRC is just one part of UKRI. We do work closely with Innovate UK in areas like this as well. If you could go to the next slide, please, Pete. Thank you. So this slide here is just demonstrating the EPSRC manufacturing and circular economy theme research priorities for the coming few years. This isn't published yet, but we are talking about it openly. Just gives you a bit of a flavour of what we're doing. Given the time that I've got, I'm not going to go into every individual part of this and explain what they are. But as I said before, please get in touch with me or any member of the EPSRC team, and we'll be very, very happy to talk you through what this means for you. I know not everybody in this audience is going to be completely aligned to manufacturing and circular economy as well. But from our perspective, research in residence form a really important part of our ecosystem. The priorities that we've got identified here don't encompass everything that we do, nor everything that we're funding, but they do represent the areas that we'll be looking to drive forward through targeted interventions, including funding, but also through other mechanisms. The priorities will be under review. We'll continue to go with how the community is developing. But these technological developments that we're trying to achieve cannot be done without the cross-cutting principles that you can see on the left-hand side. And in order for us to achieve that world-leading high-impact manufacturing and circular economy research, to achieve that vision, we really do need to drive active engagement with stakeholders, have interdisciplinary co-creation, develop people and skills, as well as embedding that environmental sustainability. And we see the Researchers in Residence scheme as helping to achieve some of these. We really think that they can be really valuable for people's careers and also help us to get that active engagement and cross learning that we don't get through other mechanisms. And we see this Network Plus as a clear route to helping us achieve some of our broader ambitions. And this can be applied to a lot of EPSRC themes as well, but these are ones that we as manufacturing and circular economy are really driving. If I could have the next slide, please. So in terms of more broadly in EPSRC, Researchers in Residence Awards and this network and scheme, as I've mentioned, they form part of a broad suite of activities. We also have impact acceleration accounts, prosperity partnerships, and innovation and knowledge centres, all helping to drive forward that broader ambition. And Researchers in Residence form a really key part of that. They're fairly small awards in and of themselves, but the difference that we can anecdotally know that they make can be really massive. However, we would really appreciate hearing more from people that are involved in this scheme. What makes you want to apply when you have been successful? What you're getting out of it, what impacts you're having, and help us to demonstrate the benefit that we see and know is happening, but so that we can articulate that better. Especially in the context of where we are with government and spending reviews and all the uncertainty, it's really great to have that impact given to us. There are different types of impact, and it can mean something different to everybody. Across multiple researchers, across multiple sectors, impact in your space is going to be different from impact in someone else's area. But broadly, the sort of things that we'd be looking for in terms of impact from this scheme, progressing your field, developing new tools, thinking about where your work can progress, who you're working with, regionally as well, potentially, and the knowledge that you're gaining for your subject, for your discipline, and for yourself. Society, so the impact that we're having on society, and the public engagement that we are getting, and how we're disseminating findings, and what you're getting from this scheme, and more broadly what you're doing, and how we're making sure that we're educating society as well. People, and by this we mean as individuals, how we're helping early career researchers, how we're helping to develop long-term growth and prosperity, and creating that strong research base for the future. And economic, I think, is what it is. Great way of evidencing development with business and with academia, and how we can really drive through some economic advancements in some of these areas. No one type of impact is more important than another, but we see a broad and varied thing, but we want to know about it. It's really helpful if you get in touch with Reese, myself, Amanda in EPSRC, generic inboxes as well. Put things on LinkedIn. We do watch you on LinkedIn. We do like to engage with people, and that helps us to demonstrate what's going on. So I've kept that as brief as I can, because I won't be able to be here for the questions later. So I've left just, I don't know if that's in your agenda, Pete, but I've left a tiny bit in case there's any immediate questions.
That's fine. So if anyone does have any questions for Lydia before she has to leave us shortly, we've probably got an opportunity now for, let's say, 2 or 3 questions if anyone has them now. So if you drop, if you raise a hand, that's probably the easiest way of asking a question verbally. Or if you want to put it in the chat, if you ask your question in the chat window, then we can use some of that time with Lydia now. Alternatively, if you can't think of your question now, I think Reese is going to be around to the end of the session, and I'm sure Reese will either be able to answer the question himself, or take that back to answer at a later date.
Also, we are people as well, and we're always available for you to get in touch with any questions, even if it's not about this, but particularly around this. We're very keen to engage.
So I'm just going to quickly check the chat window to make sure we've not had anybody. No, we haven't had any questions in the chat. So I think you've done a brilliant job of explaining everything in that case, Lydia. So so thank you for doing that. And if anyone does have any questions come up during the course of the next 40 or so minutes, feel free to drop those questions in the chat. We'll either address them as we go along, or we'll I guess signpost you to a little bit later in the agenda when we're going to cover the answer to that. Equally, if we haven't got an agenda point, we do have another opportunity at the end of the session for questions, and we can either answer them directly, or we can go away and find the answer if it's a less obvious question that we don't know the answer to yet. So thank you, Lydia. The next item in the agenda is really to understand a little bit more about the Catapult Network. And I think many of you will already be familiar with Catapults and what they do. But we've got a quick video now, which is going to cover the different areas, what each of the, well, to a certain extent, the different activities that Catapults get involved in, and hopefully start to give you a flavour for how your work can interface with them. Is this now not playing?
Catapults are technology and innovation centres that bring together into one place domain expertise, physical assets, intellectual property assets, capabilities, and industrial networks to enable innovation that leads to greater productivity and growth.
There are 9 catapults altogether, and each one of them specialise in a different thing. So businesses have a wide range of choice as to how they can get this help.
Catapults help UK business and industry by helping companies of all shapes and sizes to seize their opportunities and also test and demonstrate their ideas to help them get their ideas to market faster.
We're really helping to address the levelling up agenda. We're working to engage with businesses outside of the South East. We're helping to understand where the expertise resides across the UK and building capability maps of both businesses and academic expertise, which we can use to form technology innovation clusters or help bring a focus technology area to any one of our clusters.
There's 50 different centres in all of the 4 corners of the United Kingdom, and all of those centres are delivering prosperity in local areas, whether it's Orgreave near Sheffield, where you've got the Advanced Manufacturing Research Centre, seeing investment from Rolls-Royce and Boeing, whether it's Stevenage in the southeast and the cluster created around cell and gene therapy, or whether it's Blythe up in the northeast, where they're testing world-leading innovations around offshore wind and helping regenerate that area around the energy opportunity that comes from the net zero transition.
Blythe used to be predominantly a mining town. The port of Blythe actually set records in the 1960s for exporting coal, and since then obviously it's transitioned to offshore renewables. In both cases they were ideally placed, so they had a lot of coal mines within 5 miles of our location here. And nowadays, because we're right by the North Sea, we are in a prime position to help support and innovate in terms of offshore wind. The Port of Blythe here is used for offshore installations.
As a Catapult, we set out our problems and our challenges that we see in representing the business communities that we work with, and we ask for academic experts to help solve some of those challenges.
Catapults help UK business and industry by being a bridge between academia and business. And you may see alongside me this incredible motorbike which has been developed into an electric bike by a group of students based here at the university.
Catapults have a crucial role in taking that insight from the innovators we work with and helping government and regulators think through what the changes that are going to be needed so that we can unlock the markets of the future.
Catapults are hungry for talent and are distributed across the UK. They reach into communities to find the best talent regardless of where it comes from, and enable that talent to participate in the thriving and exciting industries that Catapults represent.
Everybody is included in everything that we do. We're asked to bring our whole selves to work. It doesn't really matter about your background, your expertise level, your seniority in the business. We're a culture that supports innovation, and that means through everything that we do.
The role of Catapults in terms of encouraging diverse talent throughout the UK is a subject very, very dear to my heart, and I'm incredibly proud we launched the Inclusivity and Innovation Charter. This again was a real stake in the ground in terms of how all our catapults can work together. Retaining, recruiting and engaging our staff, our talent, our future workforce is second to none in terms of importance. And that has come about as a result of Catapult funding through Innovate UK.
So that was a very quick overview of what the Catapults are and the type of work that they get involved in.
Catapults
It's
are technology.
so good it wants to play again. There we go. Saw a couple of questions come up in the chat while we were doing that. So I will just, I guess, address the main one, which was whether or not the scheme was just for engineers and scientists. and I think Lydia answered it very well. Obviously, as long as the outcome addresses one of the theme areas that the EPSRC is interested in, or in fact also the Catapult network is interested in, then that's fine. And I think in previous tranches of the scheme, we've had a whole range of different applicants, from people looking at the psychology of digital systems and how we as humans get involved in them. We've had mathematicians, we've had data scientists. So it's more about the project that you're proposing and how it goes on to achieve the mutually beneficial outcome that you want to get with Catapult that's of interest, rather than your topic area, rather than the particular faculty or school or department that you work in. And as I think Paul has just put in the chat, have a look at some of the previous projects that are on the website, and you'll see quite a wide range of different topic areas, of different types of projects. And hopefully that will give you some inspiration for types of projects that you could propose, and the type of work that's possible. I'm just going to recap though now, and look at the distribution of the Catapult centres, and there's more information on the Innovation Launchpad Network website, which I think Paul has shared the address in the chat window for you to go and find, but it's innovationlaunchpad.ac.uk. Have a look on there, and it will give you a little bit more detail about the types of topics that the different catapults are interested in. But just for clarity, we're covering all 9 of the current catapults within this call. So that includes cell and gene therapy, compound semiconductor applications, connected places, the digital catapult, energy systems, the high value manufacturing catapult, medicines discovery catapult, offshore renewable energy, and satellite applications. And if you look on that map, you'll see that they've got a host of different sites dotted around the UK. And if you go onto the website, you'll see that each of them has got a key contact. So if you've got a project that you would like to discuss with them, get in touch with that key contact, and hopefully they will be able to link you up with the relevant technology specialist or industry specialist to help with your project activity. Because the key thing for all of these project proposals is that they have to be collaborative. This is an opportunity to bring people together to jointly solve the big societal challenges that we all face. And to do that, then we need to work together. And this slide's really just about reiterating that. So it is really important that you discuss your proposal with Catapult, both to check that it fits with their areas of interest, but also to give you a clear understanding of, well, what are the capabilities that they have in-house and what can they offer to that activity. So I'll just leave that link up on screen in case anyone wants to note it down. But get in touch with them, discuss what you want to do, and they will hopefully be able to tell you whether or not that fits with their current strategy. I think I saw a question come up in the chat about whether the medicines discovery catapult were interested in medical devices. I think it would depend on what you are looking to develop with that medical device. So it might fit in with their remit. Equally, if it was more related to the manufacture of that medical device, it might fit into the remit of the high value manufacturing catapult. So have a think about what the exact scope of that project activity is, and see if see where you think it best fits. I think I also saw a question come up about outreach activities. Again, I think it would depend on what the outreach activity is. Obviously, the catapults themselves will be quite well set up to reach out into industry. So they will be able to advise how they can support that activity. I guess with any outreach activity, it would depend on whether that's supporting the research activity or the innovation activity that you're proposing. So it's difficult to give a single answer. It would depend on exactly what the fit is to the project activity and whether that makes sense. And then I think the final question that came up was over the duration of the task. So you've got quite flexible duration, as long as the project is finished by the 31st of March 2026, which is when the grant finishes. It can be structured in any way. When we started off, we were working on the basis that it would buy about 6 months of the senior academic's time, but that 6 months could be in a 6-month block. It could be about half of their time over 12 months, third of their time over 18 months, or any of those combinations. So really the only hard and fast rule is that it has to be finished by the 31st of March 2026, because ultimately if you submit your invoice after that, we can't pay you. And I'm sure your university will be a little bit upset about that. But if you've got an alternative proposal in mind, get in touch and we can talk through it and we can advise on whether we think it would be possible or not. So hopefully that's got you thinking about the types of projects and the structure of those projects. We're now going to introduce you to some of the people that have already got their funding. And they're going to be talking you a little bit through about their journey, about their project, and ultimately what it's going to help them to do. So first up, I'm going to introduce you to Dr. Matt Unthank, Professor of Chemistry at the University of Northumbria University, who's going to be talking you through his project. So, Matt, hopefully you've also been given presenter rights. Can you see the controls for your slides?
Yeah, so my project's around, or the project that I'm kind of just starting as a researcher in residence is around the development of sustainable and recyclable plastics and materials. I thought I'd just give you a quick introduction into my background, so you could just, mainly because it's relevant to how I ended up proposing the work that I did propose. So this is me. So I have a PhD in organic chemistry, but then I actually, after my PhD, went straight into industry. So I spent 4 years as a process development chemist at GlaxoSmithKline, which was quite interesting actually, because then I sort of got very interested in how you scale up chemical processes from the lab into pilot plants and then into manufacturing plants. And then that allowed me to then switch industries a few years later, and I moved over to bulk chemicals and the polymer industry. And that's how I got into polymer and materials research, really. So I did that for about 8 or 9 years at AkzoNobel. AkzoNobel are one of the biggest coatings companies in the world. They're the companies that own Dulux and lots of other brands that you'll see in B&Q, etc. And so I ended up as a polymer research leader in that group. So then about 5 years ago, I'd worked with universities quite a lot actually as in my industrial jobs. But about 5 years ago, I was offered a full-time position at Northumbria University, and then most recently was made professor just this year. And my research areas really fall into 2 categories. So one in sustainable materials for coatings, composites and plastics. And that's what I'm going to talk about today, really, because that's what the theme of my research and residence application was. And then we also do quite a lot of work in functional coatings and surfaces, again with a kind of view to scale up in industrial research and applications, mainly because of my background. That's what I know a lot about. Okay, next slide. Okay, so just as a little bit of background to my project, and I've worked for a long time in the field of epoxy resins, and epoxy resins, for those of you who don't know, are one of the most common components of high performance composites, coatings and adhesives. So they're a very high volume commodity building block for lots of different polymers. And they're renowned for their strength and durability, insulation and adhesion, and for use in extreme environments. So just the pictures along the bottom just show the kind of places that epoxy resins are used. So they're used for manufacture of thermoset carbon fiber reinforced plastics. They're used for anti-corrosive paints for the bottoms of ships and oil rigs, for chemical refineries and oil tankers and all these sorts of things. They're also the main polymeric component in wind turbine blades, as well as in lightweight transport for cars or for aircraft, etc. and this is the area that I've worked in for quite a long time. So next slide. So just focusing in then on the kind of green energy and wind blade kind of problem. So I guess a lot of people might be aware that carbon fiber composites, so these are actually epoxy composites, they're used to make wind turbine blades, and they're essential really because without them you couldn't have very large lightweight structures like wind turbine blades. If you had to make those out of metal, they'd be too heavy to move, so they're made out of carbon fiber reinforced plastics. And the problem with them really is that they've been designed to be almost indestructible, so they have to replace metallic components, and for those reasons they're built to be extremely strong. By definition, if you build something to be indestructible, you then have a bit of a problem at the end of life. So how do you then recycle or deconstruct materials that you've designed to be indestructible? And so just as one example of where carbon fiber epoxy composites are used, there's estimated to be, this is probably a huge underestimate these days, but because this number's a little bit old, but 250,000 tons of epoxy polymer residing in these wind blades that are coming to their end of their life, and these effectively will be either incinerated or sent to landfill. And the reason for that is because there's no effective method to recover and recycle the polymer and the other non-polymeric components from these structures, just because of the way that they're designed on a molecular level. Next slide. So we were sort of working in the area of trying to design materials that instead of being 100% indestructible, we thought perhaps we could design materials that were 99.9% indestructible, where the conditions for deconstructing those polymers were so special that that material would never encounter those conditions in its operational life. So if you designed materials that were only 99.9% indestructible, and then you could then take them down, deconstruct the polymers and recover the polymer and the non-polymeric components from those composites. So that means you could get the fibers back, you could get any fillers back, you could separate plastic from metal, plastic from wood, etc. And therefore you would be designing structures that effectively were designed to be recycled or even repaired. So we thought that was quite a useful idea. Next slide. And this is basically just a little illustration to show what these materials do and how they're different to normal thermosets. So on the left, we've got some little fragments of a normal thermoset polymer. This is just an epoxy amine thermoset. And if you hot press, so if you apply pressure and heat to that material, other than going a little bit more yellow, you don't really expect any change. Thermosets have no flow. They can't be remolded or recycled. But our recyclable thermosets, even though they behave like thermosets at normal temperatures, so at non-elevated temperatures, if you apply pressure and heat, then you can they have some flow and can be remolded back into objects. So that's unusual behavior for a thermoset material. Next slide. And perhaps even more interesting was that this idea that we could apply some very specialist chemical conditions and effectively deconstruct those polymers and be able to get the polymer components back and separate those from non-polymeric components. And this just shows our material along the top. You can see that this is just an aggressive organic solvent, and the materials are insoluble in that, and they remain insoluble no matter how long you leave them for. However, if we add a little bit of one of our effectively deconstructing agents to deconstruct the molecular structure, eventually those polymer samples completely dissolve. And so because they're dissolved, you can then in principle separate them. And you can read all about this in our recent publication if you're interested. Next slide. Okay, so what we then, what I proposed as the research in residence proposal was really trying to get this idea out of my labs and into and scale this up and try to demonstrate this on a larger scale. And so the the project ended up as a collaboration between myself at Northumbria University, the CPI, Centre for Process Innovation down in Sedgefield, which is part of the High Value Manufacturing Catapult, and then also the National Composites Centre. And this was just a little picture that I took from my original proposal, which was just supposed to be showing this this sustainable materials collaboration between the 3 different partners, and then explaining what each partner was going to bring to the party. Next slide. So I was also asked just to give a little overview of, you know, what that process looked like for me, and I'm sure it'll be very different for other people. But this is what I did in order to get to the point of submission, was that I spoke to someone who'd already completed a Researcher in Residence award, so a friend of mine, James Kratz at Bristol. I also contacted the CPI because I knew some people who worked there anyway, so that was quite useful for me. But I understand that Pete or you know, someone within the Researcher in Residence scheme will help you with that if you don't already know someone in a catapult. And through that, I was introduced to people at the National Composite Centre that I didn't already know, so that was new contacts for me. So I proposed the topic, and I effectively pitched it via a presentation similar to the one I just showed you to the CPI and the NCC, who then agreed that that was within their remit and areas of interests and expertise, and they agreed to support the application. The actual writing of the application, I did most of that. There were parts of it around realising impact and fitting with strategic priorities that the CPI and NCC helped me with. So that was very useful as well. Next slide. And then just finally, like I said, I'm quite close to the start of this journey. I've been working on the technology for a long time, but in terms of doing it through the Research and Residence scheme, this is quite new. My main activities have been the dreaded collaboration agreement, which was made slightly more complicated by the fact that it was a 3-way agreement. I kind of naively thought that because both the NCC and the CPI were part of the same catapult, that would be one thing, but it's not one thing. That's actually 2 things, and they don't necessarily want the same terms and conditions or wording in documents. So that has taken a little while to sort out. I attended the Researcher in Residence kickoff meeting in Birmingham for my group, and that was really useful as well. But I guess the biggest output so far, and it's one of the things that I was sort of hoping would happen, is that the CPI have helped me coordinate a large Horizon Europe application based on these ideas, and bringing in the partners from their networks to sort of complete that whole package of collaborators that you need for those sorts of applications. So that's really good. And yeah, I'm happy to answer any questions if there's time, or I'm happy to be contacted for help or comments offline if that's better. Okay, that's it.
So thanks, Matt. That was a really great overview of your project. We're a little bit behind on time, so if it's okay with you, we'll hold any questions for after Beatrice and Salome have presented their work, and we've got, I guess, got a little bit of time at the end to for any questions that people have. So that takes us on to our next pair of presenters. And I mentioned earlier on that a proposal doesn't have to be from just one person. If it makes sense, there can be a pair or a team of you. I'm going to hand over to one such example of that now. So over to you, ladies, and if you can introduce us to you and to your work.
Thank you.
Thanks. So we've been asked to talk about our experience so far, so a bit about our project, what we're hoping to get out of the experience, and the process of applying, and a few points on our first week. So that's now slide 2.
So treatments based on nucleic acids have huge potential, and our mission is to enable the rapid development of the ever-broadening range of nucleic acid therapies to treat diseases that have no current cure. In particular, the 95% of rare diseases that have no FDA-approved treatment. And gene therapy is likely to be the answer to this, and our technology should help make that a reality.
Next slide, please. So when a manufacturer or a researcher wants to generate DNA, they first need to be synthesized. So de novo synthesis can be high throughput and automated, but only makes very little of the template DNA. They therefore need to make a lot more of the DNA template to administer a therapeutic dose, or to test their product properly. So the method for manufacturing DNA has not changed substantially since the 1970s, hence this beautiful picture, and it has a number of serious limitations. For anyone who's never worked with DNA manufacture, it's expensive, it's time consuming, and a scientist in the lab might spend a couple of weeks just preparing and growing the cells, and 8 to 48 hours to extract the DNA, after all of which they might find themselves with very low yields. Next slide, please.
Oh, sorry. So E. coli cells want to make more plasmid unless they are forced to. This usually means adding antibiotics and an antibiotic-resistant sequence to the DNA. This should be removed before transfecting the patient, or it can reduce efficacy and safety and upset the regulators. There isn't sufficient supply to meet demand. Suppliers will therefore prioritize the bigger players, large-scale pharma, which leaves academia and smaller companies waiting for months on each order, with no guarantee on exactly how much they will get, and sometimes a high error level. In processes like cell therapy or any personalized treatment where logistics are complicated, this adds to the overall difficulty and therefore cost, and slows down the design, build, test cycle. Because it uses lots of high energy equipment over multiple steps and sometimes requires separate facilities from other activities, it is costly both for the user and for the planet. Next slide, please.
Cell-free methods for producing DNA are closer to a simple chemical reaction. So they're therefore more predictable, and there's no host cell genome for your plasmids to interact with. So you're likely to get a low error rate. And because we have direct access to all the components, we can have a greater control of quality. Number two, just like taking out the middlemen, removing cells means that more of the energy goes into producing the final product. For this reason, cell-free is highly efficient. With a still semi-optimized process, we can get 20 grams per litre, which is massively higher than cell-based, within a couple of days. And number three, finally, even ignoring the more efficient process, it's much cheaper for the user and for the environment. So our technology will reduce the cost and time of DNA production for our customers, our potential customers in the future, by more than half. Next slide, please.
So we want to commercialize a standalone automated DNA production device that will be an integral part of future biomanufacturing and biotechnology labs. Such device can be used to speed up the design build test cycle for nucleic acid therapies and later for distributed, localized, and on-demand manufacture for clinical applications. The subject of our R&R project is the development of the purification part of this device. So it needs to consist of as few steps as possible and purification methods which are amenable to automation in a simple device and based on liquid flows alone. The following few slides summarize very briefly the challenge we hope to address with the R&R project. Next slide, please.
So we know that the DNA our process produces, sorry, that was the previous slide, is not exactly like the DNA produced by cell-based production. So it is a higher initial purity and concentration, different background buffers and small molecule content, and for now at least, degree of supercoiling. Next slide, please.
We already know that conventional purification kits perform poorly in purification our DNA. We have seen very low yields from our attempts at purification to date. Next slide, please.
We also know that this technology has a very broad range of, very broad potential. So we can potentially make lots of different types of DNA using this method. But this means that we might need different purification methods for each. For example, if we want to use it for therapeutic applications, it needs to be very pure, and we need to make sure that we separate it from other similar species that might be in the mix. Next slide, please.
So by gathering high throughput data on a range of purification resins, which rely on different purification properties, we are aiming to be able to improve the purification of our DNA and to have the flexibility to pivot to different applications. Next slide, please.
So this little timeline here is just illustrating how we got to where we currently are, at least within the Researcher in Residence project. So about a year ago, we were attending a similar launch event to this one that we're currently at, and subsequently went to our PIs, the two of us, with 3 ideas for potential projects. We then contacted CPI, that's the Centre for Process Innovation, and Cell and Gene Therapy Catapult. Cell and Gene Therapy got back to us and said they concentrate more on viral vectors than plasmids, therefore thank you but no thank you. However, CPI were interested in working with us. So I should say we had previously had a sort of some superficial work with CPI before. We'd done a couple of collaborative paper with them, but this was aiming to sort of deepen that relationship and get us access to the actual equipment and facilities, knowledge, etc. So we put together an expression of interest, which was refined in collaboration with CPI, our TRO and our PIs, of course, and were invited to full application. So we had the third, sort of the next development steps with CPI involved a telecom where we narrowed down our 3 ideas to 2, and then we went up in person to sort of present the 2 possible scopes for projects involving the 2 remaining ideas. And they helped us narrow down to the sort of one that they thought they were best placed to support us with and that they thought would have the biggest impact commercially. So this was very much based on their input. I suppose it's probably worth also stating that because our project is aimed at commercialisation, we knew from the start that we needed to be thinking about IP, and if we were developing IP in collaboration with Catapult, how that might complicate later stages. So the arrangement we came to with CPI was that we would be taking essentially control of all the sort of say creative elements of the project, so development of the ideas and the approach, and CPI will be essentially providing facilities and generic advice based on their expertise. So just, I guess, to make people aware if that's an issue in your particular case. So so CPI were able to sort of review our draft and help to sort of refine it, but the main core of the project was based on our own design. We then so obviously it went through, but I guess the other thing that is probably worth highlighting on this timeline. So we initially thought that we would be able, having received the go-ahead in March, to be able to start the project in July. It turns out, and again, this may be sort of old news to people that are sort of long-term academics, unlike ourselves, that putting together a collaboration agreement is quite a lengthy process. In our case, not because we were working with more than one catapult, but because things on our side at UCL were quite slow. So we did finally manage to finalise a collaboration agreement only in December, and a couple of weeks ago attended our first week at CPI, which I think we would say was a good experience. We had our own we had our own Dutch initial training. People were very enthusiastic, happy to meet us.
It's an amazing environment, and we are willing to continue the project. We have access to everything. They are very low profile when it comes to discuss ideas and all the work. So it was very a fruitful week.
And I think we already learned a little bit more so that we understand how we need to adapt our project already to make it more realistic with the material and the equipment that's there. And I think that's more or less everything we had to say
for now.
So thank you both, and thank you to Matt as well. I think you've both given you've all given really good overviews of your projects, and hopefully inspired people to start thinking about what form could their project take. I think we obviously had 2 examples there with CPI where they'd got very hands-on and they'd helped to develop the project, and certainly reviewed and provided assistance on the scope, and that's definitely a key bit. I think if there's any advice that we can give in terms of what makes a successful researchers in residence project, but I think the one thing that has differentiated those which were successful from ones which weren't was the collaboration that's gone into its creation. If you look at the good proposals, they are clearly collaborative. They come across as being having been co-created. Those which were less successful haven't been able to articulate that. So if there's one piece of advice I can give to people, it's to get in touch with Catapult that they want to work with as soon as they possibly can, and develop your idea with them, because then hopefully it will turn into the best version of that idea, and you stand a much better chance of success. It was also good that Beatrice and Salome put their timeline, and that leads us to the next sort of block of information. So key steps coming up. We're launching Tranche 3 today, and I mentioned the expression of interest deadline. You'll find an expression of interest form via the Innovation Launchpad Network Plus website, and that's innovationlaunchpad.ac.uk. Have a look on that. You'll find the form to fill in. We have an expression of interest deadline of the 30th of November, and Paul has shared the link to that in the chat as well. There are actually two slightly different versions of the address. Both of them will take you to the same place. There is an internal and an external version. They should both work. Submit your expression of interest via the website. There is a deadline of the 30th of November, as I say. If you get your expression of interest in earlier, it will allow us more time to process it, and will allow you to start on your full application earlier. The full application deadline is actually the 25th of January. And for that, we need a letter of support from your institution. So that needs to come from whoever your head of department is, and it needs to confirm their support for you doing the activity, and that you have the time available in your workload to support whatever your activity is. After the 25th of December, we'll then put those through a review process, which will take on both the scientific review from a peer within the academic community, and also a Catapult review from the Catapult that you want to work with. And we're aiming to announce those decisions by the end of March 2024, which is about the same as we had with Tranche 1. And so you can kind of work back from those dates. You can scale the dates that they gave in the previous slides to work out roughly when you should expect to start working. I will, I guess, iterate again what was said in the last presentation. It is really important to get that collaboration agreement in place, particularly if you're wanting to own the IP that results from the work, as the last presenters did. So put enough time in place for it to get created. Make sure it isn't forgotten, because it potentially can hold up the process. So that was the end of the formal presentation. Done okay on time. I guess the key thing is, if you've got any questions, we've got a short amount of time now to go through any of those questions. I think we've had 2 come up in the chat. Alternatively, if one comes up later, feel free to get in touch. You can either get in touch to me directly, and my email address is on screen, or you can get in touch through the website, innovationlaunchpad.ac.uk, through our, I'm still going to struggle to call it X, through our Twitter, or the platform formerly known as Twitter, where we are Innovation Launchpad ILN_plus, or through our LinkedIn channel, or you can email us on rnrapplications.ac.uk, is that correct? Or .sheffield.ac.uk. So let's try and address some of these questions in the chat.
The first one is from about the Catapult Network interested in management business strategy and action?
I think the answer to that is possibly. So have a think about which of the catapults it might be most closely related to. Most of the catapults will now be starting to think about how their particular field of interest affects the climate. I know from our own work here in Sheffield at the AMRC, sustainability and climate impact of manufacturing is a big theme now. So have a think about which of the catapults might be most appropriate to work with. And again, get in touch with them to discuss whether it's of interest and how it may fit with their strategy. So second question, I think is from, is it Jason? I'm not entirely sure I understand your question. Do you want to ask it on the, well, do you want to unmute your microphone and ask it online, and then perhaps we can explore it a little bit more?
Hi, can you hear me? Hi.
Hi.
Peter, can you hear me?
You're a little bit quiet.
Okay. I'm not sure. Maybe network interruption is there, because several times I was out because due to lack of internet issues. My question was the 50K project. So when I will submit the project, whether you are focusing only accommodation, traveling, and consumable cost, this sort of only, or I have to show such a big project plan, entirely like a design simulation of some prototypes. I'm saying in such a way because my specialization is more design, modeling, and prototype design sort of things, fabrication sort of things. So I wanted to know whether the proposal would be complete till fabrication stage, or just to show about the project plans, and then just traveling sort of things, accommodation and consumable cost a bit, yeah.
Okay, so I think I heard that. You're a little bit quiet, so it was a little bit difficult to hear exactly what you were saying. However, I guess there's a couple of bits to that answer. So yes, we will definitely need a project plan which explains what the activities are, so that we can get a good idea what is going to be done as part of the project. In terms of the 50K funding and what it needs to be allocated to, the researcher and resident grant will essentially buy out your time and provide travel and subsistence funds to get you to the catapult and back at whatever interval is required. And it can also be used to pay for some of the consumable costs. I think for your particular example, where you're looking for something to be designed, modeled, simulated, and potentially prototyped, that probably pushes you down the route of working with one of the high value manufacturing catapult centers, because you need that prototype fabrication, and they will have some budget available from the HVM catapult to help with the fabrication and equipment, and potentially some of their staff time in support of your activity. But again, it probably comes back to having a really good conversation with them to understand, well, what equipment do they have? What capability does that center have? And then you can work up a proposal together. And if you have any further questions, feel free to get in touch with either myself or Christina Parry, who's the network manager, or one of the other team members, and we'll be able to help answer those.
Thank you. I got it. Yeah, I will do.
I've seen a couple of other questions.
Yeah, so Thomas was asked the same question about sort of funding rates. How's the competition rate? So
okay, so in terms of roughly what percentage, so I think so far roughly 2/3 of the applicants have been successful. So relatively high chance of success. But I will point out, those people who have been successful have worked quite closely with Catapult that they want to work with to build their application, as both Matt and Beatrice and Salome have highlighted in their proposals. So if you work with Catapult that you want to work with to build the presentation, you stand I would say probably a very good chance of success. So hopefully that answers. Yeah, so I guess in terms of roughly how many applications we've had, I think we have ended up, so we have a couple of the Tranche 2 proposal or applications that have a couple of outstanding questions on detail, but we think we'll have ended up funding around 75 projects at the end of the Tranche 2 process. And very roughly, I would say that was probably from about 110, 120 applications. I can also see question there from Akash. So he was you were asking whether or not any of the projects that were selected that went through the Tranche 2 EOI process, do they need to submit another EOI for Tranche 3? So if you went through the EOI process in either Tranche 1 or Tranche 2 but didn't submit a full application, you don't need to send us another, or you don't need to put in another EOI request. Just get in touch again, and as long as the project is substantially the same project, we will send you a full application form again. It is important that you do ask us again, though, because we have revised the application form slightly. So we do need you to fill in your full application on the current version of the form.
She's also asked, can a portion of this funding be used to attend conferences as well?
So that's probably a question with two answers. So if you think back to what the purpose of the funding is to allow you to work collaboratively with one of the catapults to collectively build new knowledge and apply your research to solve a problem. So if through attending that conference you are helping to do that, then yes, that might be appropriate. However, if it is just attending a conference to learn more about the topic area or the subject area, or for an unconnected reason, then the answer would be no. So in the application, you'll have to essentially explain why those costs are appropriate for the project. So I'm just checking back through the list of questions. I don't see any other questions at this stage. I'd once again like to thank all of our speakers, so Beatrice and Salome, Matt, and also Lydia right at the very beginning from the EPSRC. So thank you to all of our speakers today. Hopefully it's given you all a really good overview about what the scheme is about, and hopefully fired some new thoughts in your heads about what you would like to do. But if you have any questions that come up over the next few days, feel free to get in touch, and we will do our best to answer them. Equally, if you would like introductions to any of the catapults, get in touch, and we will connect you with the right person in the right catapult. So thank you all for your attendance today. I think Paul has said in the chat the recording of this video will be made available afterwards. It will go up on our channel on YouTube, so you can watch this back at a later date. And you'll also find on YouTube some of the videos from our previous events, some of the presentations that other researchers in residence have recorded over the last 12 months. And also our podcast, the Launchpad, where we talk about various issues related to the scheme, and hopefully answer some of the questions that might come up as you're putting together your application. So we will leave it with that, and we will hopefully see your applications coming through over the next few weeks. So thank you.